Thousands of years ago, watching the sky wasn't just a pastime. It was a method of survival. Today, I'm going to take a closer look at how the ancient Puebloans used nothing more than stone, sunlight, and careful observation to measure time with astonishing precision. I'm Gabrielle Burchak. I'm a science communicator with a background in mathematics and journalism, and this episode explores a remarkable solar marker called the Sun Dagger. Before calendars were printed, before clocks ticked, and before numbers were written, humans looked up. We looked up at the sky, not just to admire the beauty of the stars and celestial bodies, but also to predict the best times for planting and harvesting crops. So stargazing was not just an enjoyable endeavor, it was a method of survival. In the American Southwest, just northwest of Albuquerque, New Mexico, is the Chaco Culture National Historic Park in what is now known as Chaco Canyon. There, located on the Fajada Butte, is an astronomical artifact that is a mathematical solution to timekeeping, a cultural anchor, and one of the most elegant scientific instruments ever created without metal, lenses, or written mathematics. This artifact, known as the Sun Dagger, is a solar calendar created by Ancestral Puebloans. The Sun Dagger is not folklore, nor is it symbolism loosely interpreted after facts. This Sun Dagger is a precise observational tool carved into stone more than 1,000 years ago. Long before equations, long before observatories, long before modern astronomy, people across the world watched the sky with extraordinary patience. They tracked shadows, marked the sun's rising and setting points, and noticed patterns that repeated not once, but every year. This curious endeavor helped Native Americans predict when the cold winter would come, when the flowers would bloom, and when to harvest. So, who were the ancestral Puebloans? They lived in the Four Corners region of the present-day United States, roughly between 850 and 1250 CE. Their culture flourished in what is now northern New Mexico, Arizona, Utah, and Colorado. The ancestral Puebloans are known for their multi-story stone dwellings, sophisticated road systems, advanced water management, and a deep integration of cosmology into daily life. And this particular region, Chaco Canyon, was not a city in the modern sense. It was a regional center, a place that people traveled to for ceremonies, trade, and coordination across vast distances. What makes Chaco Canyon remarkable is its scale. Chacoan roads ran for miles in straight lines, often ignoring terrain in ways that suggest a ceremonial or symbolic importance rather than simple transportation. In Chaco Canyon is a large, multi-storied structure, great house called Pueblo Bonito, which means beautiful town. Pueblo Bonito was a grand, D-shaped structure that covered 3 acres and housed about 650 rooms. Parts of it were 5 stories high, and the area around it required advanced planning, labor organization, and long-term resource management. None of the structure emerged accidentally. The culture of the ancient Puebloans thought in cycles, patterns, and long spans of time. But here's the ancient problem of time. The seasons did not announce themselves, much like they do now on our weather apps and weather reports. No label on the horizon said, "Plant now." There were no calendar reminders. There were no pop-up notifications that reminded them to harvest the crops. Instead, there were subtle shifts in the lengths of shadows, the position of sunrise, and the height of the sun at noon. And for Native Americans, these shifts repeated predictably, but only if they watched carefully, very carefully. As I've noted in previous podcasts, a solar year is not an intuitive length of time. It is approximately 365.2422 days. But without writing, without numbers, without clocks, how did they track that? Well, they tracked geometry. The natives of the American land watched how light behaved in relation to fixed objects. They noticed the symmetry and they marked the extremes. And by doing this, they knew exactly what the Sun Dagger needed to do. So let's fast forward about 1,000 years to 1977, when artist, educator, and researcher Anna Sofaer volunteered to record rock art in New Mexico. At this time, she had taken a course in Mayan art and became fascinated with native and Mayan rock art. So, on her second day ever in the desert, she offered to follow experienced climber Jay Crotty up the Fajada Butte. On a whim, the two decided to climb to the top of the butte, but what she noticed was unusual. 3 large sandstone slabs were leaning against a cliff face, not naturally embedded, but deliberately positioned. Behind them were 2 spiral petroglyphs carved into the rock, one large and one small. In an interview with Robert Wilder for El Palacio magazine, Sofaer says that they, quote, saw a beautiful carved spiral in the shadow of 3 leaning large rock slabs. She noted that it was too late in the afternoon to take any photos, so they returned the next day. When they arrived at the same place near noon, she says that it was, quote, a week from solstice and a dagger of light was bisecting the spiral. It was formed by one of the openings of the 3 rock slabs in front of the spiral. Sofaer said, quote, I felt certain it was marking the summer solstice because the sharply pointed light shaft centered on the spiral created such a strong image. This particular image stood out for her because 3 months before the spring equinox, she was visiting the Mayan site Chichen Itza, where she saw a serpent shadow form on the side of the large pyramid El Castillo at sunset. Remembering this and recognizing the dagger shape of light at the Fajada Butte, she knew she had to study this further. So, she reached out to a few other academics, including the physicist Rolf Sinclair at the National Science Foundation. Together, the two began studying this. The collaboration became a 14-year endeavor to analyze the 3 slabs and the movement of the dagger of light. The whole story is in an article in El Palacio magazine, and I'm going to post that article on my website at mathsciencehistory.com, and you can find it under the link called The Transcriptorium. And as a quick side note, while you're there at mathsciencehistory.com, please consider clicking on that coffee icon and making a donation to Math Science History. Every donation you make to the podcast helps keep it up and running and covers production costs. I love what I do, even though it is more than a full-time job. Just ask my husband. So every donation you make truly helps keep me and the podcast going. We'll be right back after a quick word from my advertisers. So, back to Sofaer. As she collaborated with other academics, they discovered that the sun dagger also served a purpose at night, tracking the moonlight. They observed that the moonlight also formed patterns on the spirals. The sun dagger assisted the ancient Puebloans in understanding both solar and lunar markings. It's really fascinating because it's not a daily sundial. It is a full calendar of lunar and solar information, all created from 3 slabs and 2 spirals. It's so simple, yet so informative. And here's what's really cool. They noticed that as the sun moved throughout the year, narrow shafts of light passed between the slabs and fell across the spirals in highly specific ways. Over years of observation, their research confirmed that on the summer solstice, a single narrow shaft of sunlight, which became known as the dagger, perfectly bisects the larger spiral. On the winter solstice, 2 daggers appear, framing the spiral from both sides. And on the equinoxes, a dagger grazes the edge of the spiral. Additionally, these alignments are accurate to within 1 or 2 days, rivaling the precision of many ancient astronomical sites worldwide. This is not a coincidence. This is a well-thought-out, impeccable Native American design. So how does it work? The brilliance of the sun dagger lies in its simplicity. There are no moving parts, there are no additional markings or mechanical adjustments. It's just stone, sunlight, moonlight, and time. The 3 slabs act as a fixed aperture. As the sun's declination changes throughout the year, the angle of incoming sunlight shifts. This shifting creates a predictable movement of light and shadow across the rock face. The spirals also serve a function, providing a visual register. But the spiral does not measure hours or minutes. It marks thresholds that include the longest and shortest days, as well as the balance points between them. From a mathematical perspective, this is a bounded periodic system. The sun's path oscillates between two extremes, and the spirals capture those extremes with clarity. It's brilliant because this periodic system is observational astronomy expressed through spatial geometry. The development of the Sun Dagger was not an accidental discovery. The Sun Dagger is proof of long-term data collection. You see, American natives could not have built this in a single year. Instead, this accurate measuring system required many, many years of observation, handed down over generations. And most importantly, it wasn't just a general observation. It was a shared cultural understanding of why precision mattered. So, why did they choose spirals? It was not just an artistic flourish. It was truly mathematical. From a mathematical perspective, the spiral captures a bounded periodic system. The sun's motion oscillates between two extremes, the summer and winter solstices. This spiral maps the oscillation spatially. The center of the spiral marks the extreme, and the curve shows the distance from that extreme. And the cool thing about this is that it's unmistakably mathematical, even though no numbers are written down. And across many cultures, spirals often represent cycles, continuity, and return. However, here with the Sun Dagger, the spiral is also practical. It allows a moving line of light to interact with multiple points in a single carved figure. A straight line would give you a yes or no moment, but a spiral gives us deeper context. The spiral allowed them to not only see that the solstice had arrived, but how close they were to it. Because the spiral winds inward or outward, the moving light intersects at different points along the curve over time, and each position of this light corresponds to a slightly different date in the solar cycle. So, days before the solstice, the light would fall along the outer portion of the spiral. But as they approached the solstice, the light would move steadily inward, and at the solstice, it precisely bisected the center of the spiral. And after the solstice, the light would reverse direction and retreat outward. So the spiral acts as a continuous register rather than a binary marker. Also, observers could determine whether the solstice was days away, was imminent, or had just passed. This required generational knowledge, and here's why. By using the spiral, observers had to know which light positions repeated every year. It also showed which light positions marked a turning point. This required comparison across the years as well as shared memories. Elders would have recognized patterns that younger observers were only beginning to see. And this is why scholars today emphasize that the Sun Dagger reflects an intergenerational data collection. This was not a one-time discovery. As a result, the Sun Daggers transformed from a symbolic marker into a carefully generational calibrated instrument. The Sun Dagger was not merely an agricultural tool. It was a broader social system in which time, ritual, and community were deeply intertwined. Knowing when the solstice occurred was not simply about knowing when to plant crops. It was to know when to gather, when to honor the turning of the world, and when to reaffirm shared meaning across generations. Control of time did not reside in numbers on a page. It resided in the community's knowledge expressed through ceremony. Those who understood the movements of the sun and the moon were not distant rulers or abstract authorities. They were participants in a collective responsibility. Astronomical knowledge connected the leadership to the cosmos itself, grounding authority not in domination, but in alignment with the natural order. At Chaco Canyon, the Sun Dagger suggests that time was not passively observed, but actively announced. The arrival of a solstice was not an individual revelation or realization. It was a communal moment. Ceremonies could be coordinated, pilgrimages could be timed, and social bonds could be renewed with the confidence that the rhythm of life remained in balance. The precision of the Sun Dagger did not elevate one person above the community. Instead, it allowed the community to move forward together. This precision was not the product of a single mind or a single generation. The Sun Dagger could not have been created through casual observation or short-term experimentation. It required decades of patient watching, careful refinement, and the transmission of knowledge across generations. Elders preserved memory through story and practice. What emerged was not just an instrument, but a shared understanding of why accuracy mattered and how it sustained the community as a whole. The ancestral Puebloans did not treat the land as a resource to be extracted and discarded. They treated the land as a partner. Stone was shaped with restraint. Alignments were chosen with care. Architecture and astronomy were woven into the landscape rather than imposed upon it. The Sun Dagger exemplifies this relationship. It did not force the land to conform to the human will. Instead, it listened to the land, learned its patterns, and responded with respect. This deep attentiveness to the natural world reflects a profound humanity. The people of Chaco Canyon experienced uncertainty, hope, loss, and continuity just as we do today. They sought stability in a changing world and found it by observing the sky and grounding their lives in its rhythms. Through the Sun Dagger, they marked not only the passage of the days, but the continuity of their community across time. The destruction and disruption that later followed cannot erase this brilliance. The stone still holds the memory of generations who cared for their land, understood their place within it, and built a society guided not by conquest, but by connection. The Sun Dagger stands as a reminder that scientific insight, environmental stewardship, and human empathy are not modern inventions. They were already present, carefully etched into the living landscape of the American Southwest. Additionally, the Sun Dagger reminds us of something that is easy to forget. Science did not begin with equations on paper. It started with watching, patience, humility, and community. It began with an understanding that nature repeats itself if you pay attention. Our ancestral Puebloans did not just observe the sky. They understood it. And they left behind a reminder that long before clocks, before calendars, before observatories, humans learned to read time written in light, not by conquering nature, but by aligning with it. So as you move forward today, seizing it for all it's worth, remember to align with it. You might be surprised what Mother Nature might bring you. Carpe diem, my friends. Thank you for listening to Math, Science, History. If you enjoyed today's episode, please leave a rating and a review because those ratings and reviews really help the podcast. If you would like to listen to Math, Science, History without the ads on your podcast player, visit us at mathsciencehistory.supercast.com. There, you can sign up for a tier, which will give you early release podcasts, research notes, bonus material, and discounts on our merchandise. Also, you can find the transcripts at mathsciencehistory.com under the link called Transcriptorium. And while you're there, remember to click on that coffee button and make a donation because every single dollar that you donate supports our production costs and keeps our educational website free. And until next time, carpe diem.